Chapter 1. The CEO Mandate. Become value-driven, not data-driven. Data is the new oil. For the first time in my long tenure in the data and analytics business, the world has started to associate value to data. In fact, The Economist on their May 6, 2017 magazine cover declared, "The world's most valuable resource is no longer oil, but data," validating the digital future and putting an end to the way most organizations have previously regarded data in its collection, storage, and associated reporting as a necessary cost of doing business and one to be minimized at that. But what does data is the new oil really mean, and how will it impact organizations? In the same way that oil fueled the economic growth of the 20th century, data will be the catalyst for the economic growth of the 21st century. That data, including big data and Internet of Things, IoT data, coupled with advanced analytics such as artificial intelligence, AI, machine learning, ML, and deep learning, DL, will be the guiding and differentiating force that drives an organization's business and operational success, and ultimately their digital transformation. The data and value-driven mindsets defined. I often hear senior executives state that they want to become data-driven, as if somehow having data is valuable in itself. The value of data isn't in just having it. The value of data is determined by how you use it to create new sources of value. To exploit the economic potential of data, senior executives must transition from a data-driven mindset focused on amassing data to a value-driven mindset focused on exploiting the data to derive and drive new sources of customer, product, and operational value. Data may be the new oil or the most valuable resource in the world, but it is the customer, product, and operational analytic insights, propensities, buried in the data that will determine the winners and losers in the 21st century. Consequently, if organizations are ready to embrace that data is the new oil and data is the most valuable resource in the world, then the single most important question the organization must answer is, how effective is our organization at leveraging data and analytics to power our business and operational models? In this digitally transforming world, the only sustainable and defensible differentiation is an organization's ability to exploit the economic value of its data and analytic assets to deliver analytics-infused customer, product, service, and operational outcomes. It won't be the technology platform, whose differentiation is quickly eroded, and it won't be the user interface, which is easy to replicate in this digital-centric world. No, the source of sustainable, competitive differentiation will be the organization's ability to uncover superior customer, product, service, and operational insights, and interweave those insights into the organization's operational systems and value creation processes. Let's put the matter into context for your organization. How is your organization leveraging data and analytics to optimize key operational and business processes, mitigate security, compliance, and management risks, uncover new sources of customer, product, operational, and market revenue, create a more differentiated, compelling customer experience? Most organizations have no idea how to answer these questions because they lack a best-in-industry benchmark against which to compare themselves. Organizations need this benchmark to compare and assess their performance against the best in industry from a data and analytics usage perspective. Provide a simple and actionable roadmap to become more effective at leveraging data and analytics. Envision what good might look like for their organization. The Big Data Business Model Maturity Index is a framework that I created to help organizations. First, map or benchmark where they sit today in comparison to data and analytics best-in-industry practices, and second, provide a roadmap for becoming more effective at leveraging data and analytics to power the organization's business models. If you don't understand what good looks like from a data and analytics perspective, if you don't know how far you can push your organization to exploit the business potential of data and analytics, then how is your organization ever going to master the economics of data, analytics, and digital transformation? The mastery of the economics of data, analytics, and digital transformation is what will distinguish the winners from the losers in the 21st century. Understanding the Big Data Business Model Maturity Index phases. Let's deep dive into each phase of the Big Data Business Model Maturity Index, BDBMMI. Phase 1. Business Monitoring. The business monitoring phase seeks to monitor and report on what's happened with respect to the operations of the business. The business monitoring phase is where companies leverage business intelligence, BI, and data warehouses to generate management and operational reports and dashboards that communicate current operational status. The business monitoring phase leverages rudimentary analytics such as benchmarking against previous periods, industry benchmarks and plan and indices, brand development, customer satisfaction, product performance, financials, to identify or flag under and overperforming business areas that require more management or operational attention. Unfortunately, running your business on retrospective reports and dashboards that tell the organization what's happened is like trying to drive your car using the rear view mirror. It is easy for organizations to get lackadaisical and declare mission accomplished at the completion of this phase. And while the business monitoring phase is a great starting point, on its own the business monitoring phase is insufficient in helping organizations to become more effective at leveraging data and analytics to power their business models. Organizations must push beyond this phase if they seek to become more predictive and prescriptive in optimizing the operations of the business. And that means running smack into the dreaded analytics chasm. First off, the analytics chasm challenge is not a technology issue. Organizations have dumped tens, if not hundreds, of millions of technology dollars into that chasm. And that's what organizations have gotten wrong, chartering the information technology, IT, department to cross the analytics chasm. If organizations want to cross the analytics chasm phase to become more predictive and prescriptive in their business operations, then they need to embrace an economics mindset, not a technology mindset. And that requires senior management to let go of outdated legacy data and analytic beliefs. An economics mindset can help organizations cross the analytics chasm by transforming from an IT mentality of using data and analytics to monitor the business to a business mindset that seeks to predict what's likely to happen in order to prescribe actions to prevent or monetize that prediction. Moving beyond aggregating data to reduce storage and data management costs, to analyzing and mining all the detailed transactions and engagement data at the level of the individual, human, or device. Expanding data access from a restrictive tabular data model to providing access to all data sources, internal and external, structured and unstructured, that might yield useful customer, product, and operational insights at the level of the individual, human, or device. Transitioning from a batch data processing environment to an operational model that can process and analyze the data in real time in order to catch customers or operations in the act to create new value creation and monetization opportunities. Crossing the analytics chasm requires organizations to leverage the economics of data and analytics using a use case by use case approach to make the leap. We will discuss the use case by use case approach in more detail in Chapter 4, University of San Francisco Economic Value of Data Research paper, an approach which is the key to determining and exploiting the economic value of the organization's data. Phase 2, Business Insights. This phase seeks to uncover actionable customer, product, and operational insights buried within and across the organization's data. The business insights phase is where the organization seeks to predict what is likely to happen next with respect to its customers, products, and operations. The business insights phase explores a wide variety of internal and external data sources, using data engineering techniques, for example, data transformation, data enrichment, metadata enhancement, data blending, and a variety of advanced analytic techniques, predictive analytics, data mining, in an effort to uncover strategic, actionable, and material insights that might be useful in predicting performance. The business insights phase is where the collaboration between the business stakeholders and the data science team becomes indispensable in identifying those variables and metrics that might be better predictors of performance. The data science team seeks to identify and codify the customer, product, and operational insights, trends, patterns, and relationships buried in the data. These insights form the basis for transitioning to Phase 3, Business Optimization. Phase 3, Business Optimization. The business optimization phase seeks to embed prescriptive analytics, recommendations, and propensity scores into the operational systems in order to automate the optimization of the organization's key operational processes. These systems seek to constantly optimize their operations based upon each customer engagement or operational interaction. In this phase, organizations seek to automate parts of their business operations with advanced analytic modules that automatically optimize operational performance. This phase leverages predictive analytics, prescriptive analytics, and supervised and unsupervised ML to create specific operational recommendations. Phase 4. Insights monetization. Organizations are realizing that the best way to monetize their data isn't to sell it, but instead to leverage the customer, product, and operational insights, propensities that have been gathered throughout the business insights and business optimization phases to create new revenue or monetization opportunities. During the business insights and business optimization phases, organizations should be gathering insights, propensities, tendencies, patterns, trends, associations, relationships about their key business and operational entities. For example, customers, doctors, teachers, technicians, stores, compressors, chillers, turbines, and motors. Insights about the organization's key business and operational entities can be aggregated, mined, classified, and clustered to identify unmet or underserved customer, product, operational, and market needs. These aggregated insights form the basis for identifying and creating net new monetization or revenue opportunities such as new products, new services, new channels, new audiences, new partners, new audiences, new markets, and even new consumption models. Phase 5. Digital transformation. The final phase of the BDBMMI has as much to do with culture as it does with data and analytics. The key to digital transformation success is to create a culture that encourages the continuous exploration, creation, sharing, reuse, and refinement of an organization's digital and human assets. As we will explore in Chapter 8, the 8 laws of digital transformation. Digital transformation is about creating an environment where advanced analytics such as RL and AI, which I will cover in Chapter 6, the economics of artificial intelligence, are augmenting the capabilities of the frontline employees to explore, learn, and adapt at the point of customer engagement and operational execution. Digital transformation must also address the organization's compensation and reward structure to incentivize the business functions to share, reuse, and refine the organization's data and analytic assets. This likely means transforming how you hire, train, promote, and manage the organization to create this sharing and continuous learning and adapting culture. Now, let's understand the action plan that organizations can follow to advance up the BDBMMI. Navigating the Big Data Business Model Maturity Index. The problem with the BDBMMI is that the journey up the index is not a continuous process. There are different challenges that must be addressed at each phase as organizations seek to become more effective at leveraging data and analytics to power their business models. Let's review the steps required to transition between the BDBMMI phases. Transitioning from business monitoring to business insights. Here are the actions to transition from Phase 1, business monitoring, to Phase 2, business insights. Identify an organizational strategic business initiative. That is, what is the organization trying to accomplish over the next 12 to 18 months from a business perspective, and what are the financial, customer, and operational impacts of that initiative? Identify, validate, value, and prioritize the organization's key business and operational decisions that the key stakeholders need to make in support of the targeted strategic business initiative. Cluster the decisions into common subject areas or use cases. Capture, cleanse, normalize, transform, enrich, and make available the relevant data sources in a data lake. A data lake is a centralized data repository that allows organizations to store both structured and unstructured data at the lowest level of granularity. At the lowest or most detailed level of granularity, including historical operational and transactional data, internal unstructured data, consumer comments, technician notes, engineering specs, and external or third-party data, whether traffic, local events, economic growth metrics, financials. Create an analytics, data science, sandbox, data lake that allows the data science team to rapidly ingest data, as is, no schema required, quickly provision the necessary data engineering and data science tools. This allows the data science team to explore the data, discover patterns, trends, and relationships buried in the data, and test different combinations of data, data enrichment techniques, and analytic algorithms for their predictive capabilities in a fail-fast/learn-faster environment. Deploy and use predictive analytics to uncover potentially actionable and predictive customer, product, and operational insights. Example, propensities, preferences, patterns, trends, interests, passions, affiliations, associations, and sentiments buried in the data. Train business users to think like a data scientist, to unleash the organization's tribal knowledge and brainstorm variables and metrics that might be better predictors of performance. Create a right-time analytics capabilities that monitors individual and device behaviors to flag anomalies or behavioral changes that might be worthy of further analysis and action. Master data science capabilities including data enrichment, data visualization, statistics, diagnostic analytics, data mining, and predictive analytics. Master design thinking capabilities, such as personas, key personality or operating traits of a key stakeholder who is relevant to the problem at hand. Stakeholder maps, a relationship map between stakeholders who either impact or are impacted by the problem at hand. Envisioning, a facilitated brainstorming exercise across a diverse set of stakeholders. Facilitation, a discovery and exploration process guided by a trained facilitator. Hypothesis development, a design template that defines the criteria against which a successful data science engagement will be measured. And illustrative analytics, mocked-up analytics designed to nurture and validate stakeholder analytic requirements. Develop business case with financial and business justification and supporting return on investment, ROI analysis. Transitioning from business insights to business optimization. Here are the actions to transition from Phase 2, business insights, to Phase 3, business optimization. Evaluate the customer, product, and operational analytic insights uncovered in the business insights phase for business and operational relevance based upon the strategic, actionable, and material value of those insights with respect to the business and operational objectives of the top priority use cases. Develop prescriptive and preventative analytics. Preventative analytics are analytic outcomes that provide the analytic insights necessary to prevent an action or event from happening, in order to deliver actionable recommendations and propensity scores in support of the business and operational stakeholders' key decisions with respect to the top priority business and operational use cases. Deploy a data lake with full data management capabilities, indexing, cataloging, metadata enrichment, governance, security, that supports collaborative value creation between business stakeholders, IT, and the data science team. The data lake must support the data science team's need for rapid data ingestion, feature engineering, data exploration and discovery, data enrichment, and analytic model development and testing. Capture or store the customer, product, and operational insights in asset models, analytic profiles for humans, and digital twins for devices and machines that aggregate the analytic insights about the organization's key business entities. Leverage DevOps disciplines to operationalize the customer, product, and operational insights into the organization's key operational systems. Operationalize the prescriptive recommendations with modern DevOps techniques to embed the analytic insights, propensities, into operational systems in an easy-to-understand, easy-to-consume format. Measure decision effectiveness. Instrument the analytic recommendations in order to determine the effectiveness of the recommendations. Use the results of the effectiveness measurements to refine and fine-tune the analytic models. Master data science capabilities such as feature engineering, ML, DL, reinforcement learning, and AI. Master design thinking capabilities such as customer journey maps, mockups, prototyping, and storyboards. Master value engineering to quantify the economic value of data and analytics on the organization's top priority business and operational use cases, a topic that we will discuss in detail in Chapter 2, Value Engineering, the Secret Sauce for Data Science Success. Transitioning from business optimization to insights monetization. Here are the actions to transition from Phase 3, Business optimization to phase 4. Insights monetization. Aggregate, cluster, and classify the customer, product, and operational insights captured in the analytic profiles into new revenue or monetization opportunities. Create a rough order estimate of market size and viability of new monetization opportunities, and assess how the new opportunities leverage and slash or extend existing data and analytic digital assets. Create customer and operational journey maps to identify sources of customer and market value creation, and then map those sources of value creation against the organization's internal data and analytic capabilities for value capture. Explore new customer and market as a service consumption models that not only support the new monetization opportunities, but yield new sources of customer, product, and operational insights that can be further mined to derive and drive new sources of value. Apply data science concepts such as asset models, analytic profiles, and digital twins, a digital representation of a physical asset such as a wind turbine or a compressor, to capture and fuel new sources of customer, product, and operational value. Apply design thinking concepts such as personas, prototypes, customer journey maps, and storyboarding to validate these new sources of customer, product, and operational value. Test, validate, and operationalize the data management and data science development and production processes. Create a business plan that articulates and quantifies how the organization can operationalize these new monetization opportunities. Transitioning from insights monetization to digital transformation. And finally, here are the actions to transition from phase 4, insights monetization, to phase 5, digital transformations. Digital transformation is the creation of a continuously learning and adapting business model, AI-driven and human-empowered, that continuously seeks to identify, codify, and operationalize new, actionable customer, product, and operational insights, propensities, in order to optimize, reinvent, operational efficiency, enhance customer value creation, mitigate risk, and create new revenue opportunities. Drive business decisions by leveraging the economic value of data. Create an operational environment that continuously seeks to capture new sources of customer, product, and operational data. Leverage design thinking techniques to create a collaborative value creation culture that supports and fuels ideation and exploits innovative conflict. Force cross-organizational collaboration around purposefully constructed operational conflicts, that is, increase X while decreasing Y, to fuel envisioning, brainstorming, and organizational innovation. Create composable, reusable, continuously learning analytic modules that appreciate in value the more that they are used through the use of deep reinforcement learning and AI, something that we will cover in Chapter 6, the economics of artificial intelligence. Update the key performance indicators, KPIs, and metrics against which business progress and success will be measured. Understand any potential second-order ramifications from those KPIs, including the costs associated with false positives and false negatives when making strategic business and operational decisions. Ensure everyone in the organization has a clear line of sight from their day-to-day operations and those KPIs and metrics that measure business success. Create an analytics-enabled third-party co-creation ecosystem that enables the organization to accelerate the capture, commercialization, and monetization of the organization's intellectual property. Create intelligent apps, smart places, and smart things that are continuously learning and adapting based upon every customer engagement and operational interaction. Create a culture that leverages deep reinforcement learning and AI that empowers frontline employees so the organization never misses an opportunity to learn. Now we want to test what we have learned about the BDBMMI with a little homework assignment. Testing the Big Data Business Model Maturity Index. Let's say that your business initiative is to reduce unplanned operational downtime. That's a business objective that can apply to many industries, including manufacturing, entertainment, transportation, oil and gas, power, financial services, telecommunications, and healthcare. And with the bevy of IoT devices and sensors exploding on the marketplace, now would be the perfect time to address this wide-ranging, value-destroying operational problem. Reducing unplanned operational downtime, however, is more than just an IoT challenge, because the source of much of your unplanned operational downtime may have nothing to do with machinery and device problems. Instead, it may have lots to do with those pesky human customers and their unreliable behavioral patterns. So be sure to contemplate both human and device behavioral patterns. Crossing the analytics chasm from business monitoring to business insights. Identify, validate, value, and prioritize the use cases that comprise the unplanned operational downtime business initiative, including use cases dependencies. Supporting use cases could include demand forecasting, maintenance scheduling, inventory availability, consumables management, appropriate staffing, tools and equipment availability, and events impact. Gather potentially interesting data sources that support your top priority use cases into the data lake at the lowest level of granularity. Data sources could include sensor readings, maintenance notes, engineering specs, technician certifications and experience, consumer comments, inventory and consumables, local events, weather, traffic, economic variables, and so on. Explore a wide range of illustrative analytics using a subset of operational data to identify and validate best analytics approaches. Use statistics and predictive analytics to measure cause and effect and codify patterns, trends, relationships, and associations buried within and across the datasets. Start exploring simple analytic models to predict product, device, and human behaviors that are indicative of potential operational problems. From business insights to business optimization. Continue to test, learn, and refine your predictive models until you reach the required model accuracy level and goodness of model fit, as defined by the costs of false positives and false negatives. Repeat until model accuracy and goodness of fit meet the use case requirements. Note, you can avoid overfitting of your models by ensuring that you have defined a robust set of metrics against which to measure model performance. Create prescriptive and preventative analytics that deliver maintenance, inventory, staffing, and customer recommendations that prevent operational downtime problems. Capture customer, product, and operational insights, propensities within the asset models, digital twins for devices, analytic profiles for humans that reside in the data lake. Operationalize the prescriptive and preventative analytics by coming full circle to integrate the analytic outputs and results into the operational systems. Instrument the analytic results to capture and measure the effectiveness of the prescriptive recommendations delivered by the analytic models. From business optimization to insights monetization. Enhance and enrich asset models, digital twins for devices, analytic profiles for technicians, engineers, and customers, with propensity scores, and strength and direction of relationships and associations using graph analytics. Leverage asset models to mine, discover, aggregate, and validate unmet or underserved customer, product, operational, or market needs. Operationalize unmet or underserved customer, product, operational, or market needs to create new monetization opportunities via new products, services, markets, channels, audiences, partners, and consumption models. From insights monetization to digital transformation. Leverage digital assets, data and customer, product, and operational insights to reinvent the organization's business models to continuously capture and exploit new sources of customer and market value creation. Create composable, reusable, continuously learning analytic modules that appreciate in value the more that they are used through the use of deep reinforcement learning and AI, something that we will cover in Chapter 6, The Economics of Artificial Intelligence. Change KPIs and metrics against which the organization measures business and operational progress and success. Change hiring, management, and promotion models to create a culture of collaboration and innovative exploration. Change the compensation system to create a culture that rewards sharing and collaboration that proactively seeks to identify and eliminate business, operational, and organizational silos. Create a culture that leverages deep reinforcement learning and AI that empowers frontline employees so the organization never misses an opportunity to learn. Apply artificial intelligence to create a continuously learning and adapting, autonomous, business model that continuously seeks to identify, codify, and operationalize new actionable customer, product, and operational insights, propensities, in order to optimize, reinvent, operational efficiency, enhance customer value creation, mitigate risk, and create new revenue opportunities. Summary. Chapter 1, The CEO Mandate, Become Value-Driven, Not Data-Driven, sets the stage for the rest of the audiobook. If organizations are ready to embrace that data is the new oil and the catalyst for the economic growth of the 21st century, then addressing this question becomes paramount to the organization's digital transformation success. How effective is our organization at leveraging data and analytics to power our business models? The BDBMMI provides a benchmark against which organizations can compare themselves. But equally important, the Big Data Business Maturity Model provides a roadmap or a guide. It guides organizations in transitioning from retrospective reports that tell them what happened towards predictions as to what is likely to happen and prescriptive and preventative actions based upon those predictions. It guides organizations in helping to monetize their customer, product, and operational insights, and finally, towards digital transformation. Crossing this analytics chasm is not a technology challenge. It's an economic challenge for how organizations leverage the economic value of data to derive and drive new sources of customer, product, and operational value.